Hey there. I wanted to record a little video to walk through parts of the M2 workbook since we won't be in class together. First thing I noticed as I download the version off of the web is that it's got some formatting adjustments that need to be made. So let me share my screen and let's talk about it. This is a useful thing to know how to deal with, making columns and rows larger. So, complete the following exercises, use formulas and cell references whenever reasonable. This cell here, but the problem is that it's not big enough. So I can do a couple of things. I can make my row wider. That'll fix that. And then I see that down here, this might be slightly more important because I need to know what the headings are here. Okay, so we're talking about 6% simple interest on a $2,000 loan. I guess the place I would start before I jump into doing this problem with you is, breaking down simple interest versus compound interest. And the the key thing about simple interest, I mean, let's actually just take a step back before we jump into simple interest and compound interest. What is interest? Interest is the fee that a lender charges you. So I need money. I'm going to go to borrow some money from my friend, a bank, my mom, and the lender, the person who's lending me the money, can decide whether they're going to charge me a fee or not. And so in banking world, we call that interest. Now, simple interest is where we only calculate the fee, the interest, based on the principal. Okay, so here's another word. What is principal? So principal is the amount of money that I borrow. So if I borrow $200 and I'm going to pay simple interest, the fee that I pay will only ever be based on that $200. And the reason that that's relevant is because if I sit around and don't make payments on my principal, there's a pile of money that's growing, the charges for the interest, and I have to decide where to put that. Keep it to the side, or do I put it together with the principal? And that's the big difference between simple and compound interest, because simple interest, you calculate the interest based only on the principal, but in compound interest, the interest actually goes together with the principal. And so that has the impact of increasing the size of the principal, which means that the interest can actually get larger too. That's good if you're the lender. When you deposit money in the bank and you say, hey, take care of my money, you're actually lending the bank your money. It doesn't feel like that, but that's what's happening, because the bank isn't actually keeping your little pot of money separate from everybody else. They're dumping it all together into a big pool and doing stuff with it to try to make more money and then give you your little cut on the side. That's what banks do. Okay, so we got simple interest, compound interest. This is a simple interest question. And the key thing we need to know about simple interest is it's a relatively straightforward calculation. We're going to do the principal, it's how much we're borrowing, times the rate, times the time. And the time here is measured in years. The rate we assume is given to us as an APR, which means that's an annual rate. And so that's how we would calculate how much simple interest is generated. So in this situation, don't make payments for 10 years, $2,000 loan, 6% simple interest. We have everything we need. We've got equals PRT, P times R times T. I'm going to write it out like that, but I need to actually put in the numbers. P, the principal, 2,000. R, the rate, 6%. T, the time, 10. And so I've got my answer. It's already formatted as money, $1,200. how much will he owe after 10 years? Well, the $1,200, remember, is just the interest part of it. I still haven't made any payments. And so I still owe $2,000. So putting those together, and I'm going to use a cell reference here. We didn't talk much about cell references in week 1, but it's a really important concept that we're going to use in this table coming up here. So let's kind of brush up on this concept. The 2,000 plus D9 is really 2,000 plus 1,200. You can see from the answer 3,200. I'm going to zoom in here. That 2,000 plus 1,200 is 3,200. The way I did it, though, is I said, hey, Excel, take 2,000 and add whatever's in D9. D9 is indicating that's this column and that's this row. And that's how I get the number 1,200. So this is sort of algebraic in a way. It's sort of like computer programming. Don't get freaked out by it. You don't really have to do a lot of high-level thinking like that. It's just a reference to a box that has a number in it. All right, let's take a look at this next situation. So 6% compound interest, $2,000 loan, compounded annually. And we looked at the definition of compound interest where the interest actually gets together with the principal. So you can see in the first row, he started with $2,000. 1 year went by. So we can think of this as this 120 here. And he actually has set this up 6% times E21. I could have times 1 because I did it for a year. It doesn't make any difference because times 1 leaves me the same value. And then here I'm adding the 2,000, which is my principal, and the interest together. That's where I get the 2,120. So the key to starting the table to make autofill is to just bring this number down. There's no calculations necessary, but I want to know how much I owe at the start of the year. And if I'm looking at year 2, the start is the same as the end of year 1. And now I'm ready to autofill. This cell can be brought down. I can type the cell in and do the calculation, this times 6%. Heck, I could even type 2,120 times 6%. Oh, I forgot my equal sign. And it still gives me the same answer. But the way that we should be doing this is called autofill. And that's where we click on the cell that has the formula that we want to use. And then we go to the bottom right corner. And based on your operating system, this little symbol might look different, but you can see how I went from a thick plus sign to a thin black plus sign. And when I click then and drag, and I'm using my left mouse button and I'm clicking and I'm dragging down, it autofills the formula, changing the cell reference because the first cell reference was pointing here, and now our cell reference is pointing here. This is one of the really powerful things about Excel. All right, and then this one, if it's written properly, I should be able to autofill that too. This looks good because if I take this number plus this number, I do end up with $2,247.20. And now I'm ready to autofill the whole thing. And I can do a whole row all at once. This is really, truly remarkable. And I'm sorry that I'm not here to help you because a lot of people have trouble physically manipulating the computer to make this happen. So it is worth mentioning that if you're watching this on Monday, I have a Tuesday synchronous session. I'm going to advertise that. You can come in and ask questions, and hopefully we can get you sorted out and on your feet so that we're ready to hit Module 3 when we get there. Amount owed after 10 years without paying anything back. So this is after 1 year, after 2 years, after 3 years. This is after 10 years. I'm just going to use a cell reference and put it in there. And this is the more complicated formula that you probably use when you're doing Newton problems. And I'm going to write it out here. So the amount that you owe is equal to the principal times 1 plus the rate divided by n raised to the n times t. So we've got PRT in there. You can see the principal, the rate, and the time. All of that is still there. What's different is this letter N. So P, principal, R equals rate, T equals time. And N is a special number that tells us about the compounding. So this could be happening monthly, annually. Another way to think about it is how many times does the interest get added each year? Or how many times does the compounding happen? So um, basically, what the way it's described would be with a word. So if we go back and look at this question, it says we want to do the compound interest. If we go up and look here, it said it compounded annually. That means it happens once a year. And so in that situation, the compounding factor n is actually just one, which means that the formula is going to simplify quite a bit to just look like this: p times 1 plus r to the t power. And we got to be a little bit careful here with the Excel and how to type this. I'm going to go show you how to do it here, and then we're going to cut this video and I'll start another one for the next step. But so again, we're going to start with the equal sign. P is the $2,000. I have to multiply. I can't implicitly multiply by putting the parentheses next. 1, it's always 1 plus R is 6%. I'm compounding annually. So if I wanted to, I could do divided by 1, but it's not going to make a difference. Raising it to a power, and I'm going to do 1 times 10, because that's the number of years it is. And this number should be exactly the same as this number. So one of the things that I like in math is when we can do something two ways and kind of show ourselves like, yes, this makes sense. So this is the long way where we get to see every year, here's the interest, here it gets added on. Okay, what's the next balance? And one of the things that's nice about that is you can really see the functional increasing of the interest every year. And well, this is a bad thing since I was borrowing money. If I was depositing money, this would be a great thing. I'm earning more money every year. Every year that goes by, I earn a little more, and to the tune of $80 more by the time 10 years goes by, which is, not a lot of money, especially over 10 years, but it's increasing and it will continue to increase. And in fact, compound interest has been called the most powerful force in the universe because of this increasing factor. So for instance, if I, let's do a quick table just so I can show you a visual of this. And let's have it compound monthly. And I'll say, I'm the amount I have in my account. Let's say I start with $1,000 and I am earning 7% interest compounded monthly. And so I'm going to raise it to this number of months. And so I can do some autofill here to make sure I've set this up correctly. And I'm going to go ahead and just kind of want to see the year markers go by, but I can't think of an easy way to make that happen. So I'm just going to run this out a little bit. Let's go out. This is we're at about 30 years and my money has basically multiplied by 10. And it will continue to increase like that. If I take a look at a picture, I think a visual can be very helpful here. I'm starting to see as I go on more and more of an increase here with my curve, which is what I want to see. That's why compound interest is so powerful. Okay, I'm going to stop talking there. We've gone through 1 and 2, and we're ready to tackle some of these other questions here. But I want to make sure these videos are kind of small enough so they don't overwhelm you.